Hey YouTube, and welcome back to the IoT Developer Masterclass. So in the previous video, we were able to use Raspberry Pi to connect to our IoT service, which we hosted on Linode. In this video, we're going to do a similar thing. However, we're going to use the ESP-32. Now, the ESP-32, even though small, it's a very, very powerful microcontroller. Basically, what we're going to do is have a setup where we have two fans and two LED light bulbs and a DHT22 sensor for temperature and humidity with a few switches for control. Like you can see two switch here and another two over there, right? For controlling both the light bulbs and the switches. Very similar to what we've done previously, right? We create a group on our IoT connector application, which we are going to host. In this video, we're going to be hosting it on DigitalOcean. In the previous video, we had used the same code and hosted it on Linode. But in this video, we're just going to show that any cloud provider that you use will be able to handle and host your code, right? So you can see here, we've created our group called Francis's Atlanta Home, right? And basically there are no devices right now. Now we're going to switch on our ESP-32 device. Let me do that quickly. And now once the device comes on, it's going to connect to the internet, try connecting to the internet. Once it's connected, you can see it's now connected. It's going to also provision all the devices that are connected to it. And so now if we refresh this, you would see that it's provisioned all these devices, right? So basically it's easily done, easily provisioned, right? And then also it can send data. And now if we go into our telemetry, and once we connect, right, you see it. So basically after connecting, we can see that we have data coming in, and basically right now our red fan is off, right, and our blue fan is also off, and we can switch those on. And once those come on, you can see our red fan is now at 50 and our blue fan is now at 75. And we can also switch our LED light bulbs on. And now you can see, okay, so basically our blue LED just came on and it's at 100%, and our red LED is also on. So let's say our blue LED, we wanted to shut that off, LED, and we could say state, and we could put that off and send that, and it comes off. There's a lot we can do with this. I really hope you're able to enjoy this video and learn a few tricks about setting up IoT devices. And please feel free to like, comment, and share these videos. And now let's get into it. In a previous video, we had discussed about building a containerized IoT platform. We were able to use Docker and Raspberry Pi, right? However, in this video, we're gonna be using ESP-32. Again, so going back to our IoT architecture, essentially what we have for this is going to be almost the same. In fact, very similar to what we've done before. The only major changes that we are going to have is the new code that we would write for the ESP-32 that uses MQTT to connect to the RabbitMQ. Essentially, it would follow the same process that the Raspberry Pi had used initially, where it would connect to the RabbitMQ, although this time it will be using MQTT through the RabbitMQ MQTT plugin to connect to the RabbitMQ, right, and send data to our dashboard, our dashboard service, right, and whatever data that is being sent, right, is being picked up by the event hub, right, and the event hub routes it or saves it into the database, right? Which is then picked up by our dashboard service where our user can actually view the data. Now, basically how that happens is for the real-time data, the data is being sent over through Websockets to our dashboard. However, for time series data that's been saved into the database, that will be pulled from the database using an API. So very similar things to what we've done before. We have our multiple services, and you're going to see we're essentially running the same code. Now, there were minor modifications to enable the RabbitMQ, MQTT, but essentially the code itself is the same. Mainly the changes are from Docker Compose and some extra configurations. Now, just quickly, we have a platform solution, right, which contains our backend service, right, just REST APIs where we use Fast API using Python there, right, and then we have our database, which is MongoDB. Now, MongoDB provides us with both a way to save application data, right, and also time series data, which is really cool. So we don't have to have multiple types of databases. We could use a single database for that. Now, we're also using RabbitMQ, like we discussed, and we will be enabling the RabbitMQ MQTT plugin, and we will discuss that at a later time. Now, our dashboard, everything remains the same, uses the Node.js, JavaScript, Vue.js, and materialized CSS. Our event hub, everything remains the same. There's a minor change in the event hub. We might talk about that later. And essentially what we've done there is we create a queue that the data from the MQTT service, once we have data from MQTT, we need to be able to route it correctly to the event hub queues, right? And so we made some minor changes there where the event hub creates that necessary connection there so that once it's created, then whenever data comes, data will be routed correctly to the right queue where it's listening. And I think that's the telemetry queue. Lastly, we have our ESP-32, which will serve as our connecting device, or rather gateway, and the code in the ESP-32 will be written in Python. Previously, we had used Linode to host our services. So that's www.linode.com. However, for this video, we wouldn't be using Linode. It's the same application. Essentially, we are not changing the application, but it just shows you that whichever cloud provider you use, you could host the application anywhere. For this particular application, we would be using DigitalOcean, which is cloud.digitalocean.com. So essentially you can just go on this site, create an account. It's free. They give you like some free credit. I think it's about $200. You might need to put in a credit card or PayPal account to create it, but essentially the first $200 spending that you have will be free. So let's go ahead. You can go ahead and create an account. I already have my account. So if you prefer, you could just pause this video here, create your account, and then move on. For me, I will be logging in. So let me go ahead and log in. So if you just created your account, you would have this first project. So I think it's a default project that is created for you by default. You could use it for your applications, right, to host your web services. However, I'm just going to create a new project. So I'll create a new project called IoT Masterclass. And description will be this IoT. And we'll just say create project. So for now, we'll just skip. And now we've created this application, this project rather, IoT Masterclass. And you can see it here. We have the name IoT Masterclass. So for now, let's go ahead and create a droplet. So we'll go up here to create, and we'll click on droplets, right? And then we'll select the region. To my location, New York is closer. So it's usually preferable to pick a location that's closest to you, right? So I just pick New York, and then data center, you can pick anyone. I just leave that one there. That's fine. And then you can choose any OS image you want, right? But then you would have to install Docker because, our application needs Docker to run. So for this purpose, we will be using the marketplace. Very similar to what we did with Linode, right? We're using the marketplace. And if you go here, you could search for Docker. It's already written here for you, right? But if it's not here, you could just search for Docker, right? And you could just select that, right? So it's going to install Docker 23.06 on Ubuntu 22.04, right? So that is okay for us. That's pretty good. Now, next thing we want to do is we want to select the size of our droplet. And for this purpose, we are just going to choose basic plan, right? We'll use the basic plan, and we'll just use something cheap, regular. We'll probably need at least 4 gig. 2 gig is fine, right? It's cheap and good enough for the scale of what we're doing. We're not testing too many devices at this point. If you're running hundreds of devices or thousands of devices, that's a different thing. You might have to spend a little more. But for this particular project, we'll just use this 4 gig, 2 CPUs, 80 gig of space, and 4 terabytes of transfer. So I think that should serve our current purpose, right? So it's $24 a month. And then again, it's preferred that you use SSH key. And I can't probably stress this enough, right? It's just because this is just a training video and we need to be quick, right? We will go about setting this up, but it's preferred for security reasons that you use SSH to connect. For this, I'll just use password for my root user for connection. And let me put in my password. So, okay, there we go. So I have my password put in right now. And now I just want one droplet for now. Now we need to give our droplet a host name. So I'll use Docker IoT Masterclass. Tags, we do not need a tag. Our project, we'll leave it on IoT Masterclass. That's fine. And now let's just make sure that we selected the Docker image, because if not, we wouldn't have exactly what we need. So that's selected. Everything else looks good. And now let's create this droplet. So it should take some time to create. It should take a while. Okay, so our server droplet has been fully set up with Docker, and we have an IP address. So now let's go ahead and SSH into our droplet. So let's open Visual Studio. To SSH into our server, or droplet rather, a great tool to use is the remote development tool. From our previous video, we did discuss that, right? Where we installed this remote development tool. Very good tool. Basically, what you really need though is the remote SSH, which is also made by Microsoft, right? But if you install the remote development, it gives you like a lot of tools that are very useful as you continue your development work. Once you install remote SSH or remote development, you should have this icon down here. Sometimes it can be green, in some windows it might be blue, right? So if you click here, it'll say open a remote window. So once you click on it, let's first of all configure our host, right? So we'll go to connect to host, and we'll go to configure SSH host, and we'll click the .ssh/config. All right, and then once we do that, we can just copy one of our old settings from here, right? So let's copy this. I think this is the one from our connection to our Pi, or our Raspberry Pi project. We're gonna call this IoT Masterclass, ESP-32 DigitalOcean. You could call it whatever you want. It doesn't really matter. And then for this, we're going to need our IP address. Our host name is our IP address. So let's go here and copy that. And open Visual Studio again. Okay, paste that. And our user is root. Now, once we have this configured, we should be good to connect. So let's go ahead and connect. Now we're gonna click on that icon again, and then go to connect current window to host this time. If you click connect to host, it will open a new window during connection. If you click, but we just wanted to maintain the same window. So let's click on this. All right, and then we'll go to IoT Masterclass ESP-32 DigitalOcean, right? Once we click on that, we're gonna accept the fingerprint, and then we're gonna put in our password. Hopefully that's accepted. And now we're just gonna create, like we've done in other videos, we're gonna create a folder called applications. So make directory, mkdir, applications. And we're now going to open that folder. So let's go here and open folder, and we're going to open our applications folder that we just created. And okay, now I should ask for the password again. And I'm going to trust this. And the password again. And now we are in the applications folder right there. So the next thing we would have to do is to clone our repository. You could get it from the Code with Francis. So if you just go to Code with Francis workspace, like bitbucket.org, let's code with Francis, you should be able to get all the repos there, view all, and then you could go to whichever one. Now, the links will be provided with the video, so you might not have to worry about that. Now, we just need to copy the locations for this. So you can either open this and then copy the URL directly from there. But I'm just going to go here, highlight it, and just copy the link directly from here. So the first one I just copied now is the Docker IoT Connect API. So that's for our API. So let's go ahead and do that. So we'll open clone git repository, and we'll paste that in there, and then clone from URL, and we'll clone it into applications, and that should be done. And we'll just cancel. So you can see that's been copied down here already. Now let's do the next one, which is our event hub. We're just gonna copy the link for that, and we are going to clone git repo, paste that in there. That's for the event hub. Just confirm that, clone, and we'll put it in the applications folder, and that's all. Okay, cancel. So we have the event hub. Now the last one that we need is the dashboard. So we're just gonna copy the link for the dashboard, and we're gonna clone git repo, paste it in there, and make sure it's the dashboard, applications. Okay. And now we're just gonna cancel that, and that should be fine. Now that we've done this, right, we have our applications, the API, the dashboard, and the event hub, which is the same thing we had in our previous video that we hosted on Linode, right? We're just gonna rename this to make it a little shorter, right? So I'm just gonna rename all this. So now we've renamed our folders, right? So they look a little better. Now we just need to build this. So let's go and let's open the terminal into this folder, open integrated terminal, and that should take you directly into that folder, right? So we're in IoT Masterclass, applications, IoT Connector API, right? So now we're just gonna run our Docker Compose. Now, if you if you, let's try building this first. All right, so if you're using DigitalOcean, I think the Docker was installed using Snap. Sometimes Snap has some issues, right? And so, you might get this error here, right? Docker is installed. Like we did in our previous video, there is a extension for Docker. So let's go ahead and look for that. It's also by Microsoft. So let's go ahead and add this extension. Very great tool also. So once you've added that, you should get this tab here for Docker, and you can see our Docker is installed. We're able to connect to it, and it says there are no containers at this moment. However, you can also see that when we tried running this Docker Compose wasn't installed with our Docker, right? So let's just go ahead and install Docker Compose. So just go ahead and install Docker Compose. Yes. And that should take a while to install. Let's go ahead and run our command again to build. Let's see if it works this time. Okay, looks like our command is building properly. So while this is building, let's go ahead and look at our changes. All right, so let's go back to our Docker Compose YAML file, and you'd see we don't have that many changes per se. On the MongoDB, if we compare it to what we have on Linode, we just kind of added this local host. We only opened the database. It's just more of a security change than an actual application change, right? So that you can only access the database from the local host, so that someone from the outside can't just log in into your database. Now you can change it depending on what you want, or you can create a firewall on DigitalOcean, or if you're using Linode, you can create a firewall for that, but that's fine. However you want to do that. Now on our RabbitMQ, right? Everything is the same except that we opened up port 1883. This is for MQTT, so that we can connect to the MQTT port on the RabbitMQ, right? And also we can be able to use our normal 1883 port to talk to the MQTT port in the RabbitMQ, right? We also enable the RabbitMQ MQTT plugin. So we call in the RabbitMQ plugins and we're enabling MQTT. You don't have to enable the web MQTT. You probably just want the RabbitMQ MQTT, and that should be fine, right? The last thing we did was we set up our configuration file. So if you look here, we have this RabbitMQ config file, and essentially we just have some extra configurations that we need for our MQTT in the configuration file. So we attach the volume to it, and we are linking that there. So if you go into the rabbitmq.conf file, you would see that basically what we're saying is any device that connects to the MQTT port should forward all the messages, or generally just be connected to the IoT device command exchange. So basically this is the exchange all our MQTT data will be passing through. Now if you follow the previous code, you will notice we're using two different exchange, one for command and one for telemetry. Now we also have, and we will talk about that later, in our event hub, where we set up, if you send like a telemetry data to this exchange, right, we are collecting it and routing it. So again, the Docker Compose, I think that's pretty much all the configurations we have here, right? So let's just go ahead and deploy our application. So let's just paste that. And let's run this. And if everything runs well, we should start to see our images being built. And as they get built, they should also be loaded, right? So let's just wait on that. So it looks like we are all good at this point. Let's look at our RabbitMQ. So let's look at the logs. It takes a while for our RabbitMQ to be fully set up. So you can see our RabbitMQ, I think it's still running some commands in the logs, but that's just okay, really. That's fine. So pretty much it's gonna, okay, I think it's done now. So you can see here that it enabled it just takes maybe a few more seconds later. It enabled the RabbitMQ, MQTT, our management is also enabled, and pretty much our configurations are all set up, right? So we are good at this point. So let's go ahead and install our Event Hub. So let me go into the terminal. Let's go into this folder on the terminal for the Event Hub. And we're just gonna build. So since this is the first time we're building, we can just deploy directly. We don't have to run the Docker Compose build. We can just deploy it. So I'm just gonna paste that, and that should build and deploy at the same time. To the Event Hub, basically we made a few changes. All we added that's new is this line of code in this file in app.js to create a new queue. Usually when we use the Raspberry Pi would do all this, but because we're using MQTT this time with ESP-32, we are just gonna do this. Anytime we subscribe to this routing key, right, the message that we send on that routing key will go to this queue, which is the telemetry queue. So it's just a way we bypassed, because we can only access one exchange at a time. It's just one way that we use to bypass all that. This is the code we're using to create it, very similar to what we've done before. There's nothing much there, we're just creating and linking, and that's all. Let's go back, and now let's go to our Event Hub and view the logs. And now we can see that our Event Hub is done. We have we have our 4 consumers connected. So we have this queue linked to this exchange. So we still have one more thing we need to load, and that's our dashboard. So let's go to our dashboard, and we'll open the integrated terminal, and we'll just paste the command to build it. And once we have that, our dashboard should also be loaded. That should be fairly quick, right? So yeah, that's done. Right, so we have our dashboard also created. Right, so now if we go back to DigitalOcean, let's just get our IP address, right? And we'll just go to that IP. Our application is loaded, right? Exactly like what we had previously, right? And also, if we go to the port for the RabbitMQ, which is, let me confirm that, RabbitMQ port. So RabbitMQ management port is 15672. We should be able to access our RabbitMQ now. Let's log in and we'll see what we have configured. That's IoT Masterclass, small I, capital M, capital C, and Masterclass 9090 as password. And now, once we log in, we can see we have pretty much what we need connected, right? So we have the command topic and we have the telemetry topic. And if we go into the command topic and we go to bindings, we will see that we're binding this mqtt.publish.telemetry to the devices queue for telemetry. Previously, we used this queue. This is the queue that our consumers, that's the Event Hub, listens to, right? Any data that goes into this queue, the Event Hub will pick that up and then save it into the database and also send it to anyone or any device connected on the WebSocket as real-time data, right? So pretty much we are saying, okay, if you're connected to this routing key rather, and you are in this exchange, coming from this exchange, you can route any data connected on this routing key to this queue. And if you go into this queue, you would see that, let's go to the bindings. So basically we have the telemetry binding that we'd normally use that routes to that particular queue. So this is how the Raspberry Pi connects through this telemetry exchange, and then it also sends data through this routing key. That's device route.telemetry. So if you look at the Raspberry Pi code, you would see that. However, for our MQTT, it's using the command exchange, but it's using this routing key to push data into this particular queue. So, and any data in the queue gets picked up by our consumer. Now, let's go ahead and log into IoT Connector, and it's pretty much the same. So if we go and do admin at admin.com, which is the default user, and password is admin, since this is a new install. So once you do this, you can go in and change your password. Let's go to our ESP-32 code. So if you open up your ESP, if you go to this link will be provided where the code for the ESP-32 is, right? Where we have the code for the ESP-32. The link will be provided to this code. You would see this is the code that we're gonna use to connect and save data. So essentially, let's do a quick run through. We do have this LED PWM. There's probably some minor changes from what we've had in our previous projects, right? And we also have this environment variables.py. This is actually settings that you need to change. Items in green are probably items that you probably want to change or remember to change, right? We also have this helpers.py. These are just classes with different methods also that just simplify what we are trying to do here. So basically this method just synchronizes our NTP so that we can have the correct time, right? Connect to an NTP server and just sync up the correct time. This is just for formatting UTC date string, right? Just a function there for UTC date string. This helps us generate a UUID. Takes a UUID 4. Right, so this is a helper class for helping us connect to Wi-Fi because we just didn't want everything in the main.py. So this kind of helps us. We can use this helper class for connecting to Wi-Fi. Now this is a MQTT connector class that helps us connect to our MQTT server. Right, so just an easy class there, a simple class there. These are just data types that are defined. Right, classes for data types that are defined, objects and data, right? And then we have, this is interesting. This is our device manager class. Now this does a lot of stuff. There's a lot of stuff that this class actually does, right? So it helps you manage your devices. So you declare your devices, you can add new devices, right? You can create a device, right? You can also like, the controllers for the device are being defined also, right? So it stores the information for what type of control. So if you're creating a LED device or a temperature device, or a motor or a fan device, right? It'll be able to help you create such type of devices and define controllers for them, right? And so that you can easily be able to control them, right? So everything is kind of in there. You can go through and just check it out. Pretty straightforward. And then we have this switch device manager. This helps us manage our switch. So if you click on the switch, we're gonna trigger an interrupt and then just use that to know that the switch was pressed. This is just a class that helps us manage our switches. And I think we also have a simple class here that helps us just delay the triggering of a function. And then we have this API client that helps us make HTTP requests. So basically this is just simple classes. Yeah, that's pretty much it. Right? So if you wanted to go over the code, we're setting up the MQTT here, we're defining our devices, giving our devices name, red LED, blue LED, red fan, blue fan. So you can see the red and blue LED on this side. We don't have a fan or motor in this simulator, so we're just using LEDs also for them, but they all have switches, right? So, and then we have a thermometer and a humidity device. That's the DHT-22, has both in them, right? And then we're creating the device with our devices manager, and then you can tell it if you want to use the fan or not, right? Or if you want to use the sensor, you can set it in the environment variable if to use it or not. If you don't want to use it, that's fine. You don't have to, right? And then basically here we're getting the red and blue LED. We're getting the controller for the red and blue LED so that we can trigger them, right? So basically once you get the controller, it gives you access to the LED PWM functions, right? So you can just trigger it and say on or off directly, however you want to do it. Same thing with the fan. We also did that with the fan also, right? You can see we're getting the controller. So this devices manager class really helps simplify a lot of things so that we don't have too much code. And then here we're connecting to our Wi-Fi, right? Once we connect to our Wi-Fi, then we register the device. So basically this is our provisioning section. So we call our API that's on our backend service, our REST API service, and we ask it to provision these devices, right? So once the devices have been provisioned, then we then connect to the MQTT, and we're then able to start publishing messages every few seconds, right? So you can go through the code. We're using our MQTT connector class, right? Pretty much simplifies everything for us. The code is quite okay, right? I kind of rushed this, so please just, if there are bugs, just you can either let me know or try, just sing. It's just a test code anyways. Yeah, this is our loop, right? A while loop. Most of everything we want to do is handled already. So we're calling the function every 10 seconds. We check the states of our sensors and then we push it to the cloud. And then this we're using to check for incoming messages. When you define the MQTT connector class, we should have a callback for the subscription. So if you got a message for that particular subscription, right, that you connected to, it will call this function right here. So very easy, very simple, little code, right? Not too much code, right? And yeah, that's pretty much it. So now let's go back and connect and see how our application does. So first things first, we need to create a group. So if you try connecting without a group ID, it's not gonna work. So let's go ahead and create a group, and we'll call it, let's say I'm putting this devices in Francis home Atlanta. So we're gonna put this devices in Francis home Atlanta. Parent group, there's none, right? We don't have location. I could just say Atlanta. You don't need any of the others, so you could just create, right? So basically that's been created. If you follow the other videos, this is pretty much the same thing, right? So now that we have this, we can copy our ID, right? So let's copy our group ID, copy, and now we have to replace our group ID. So let's go ahead and replace our group ID. If the group ID is not created, it's gonna fail provisioning the devices. The IDs for gateway and devices should be unique. So if you're gonna run multiple instances, you might wanna change those, right? So our host URL, that's we'll have to change that. Our host URL is 143.198.5.161. And then this should also be the same as our MQTT broker. So just do that. And that should be all we need. If you wanted to change your device name, you could do that, or your secret key, which is going to be part of your password for your MQTT to log in. You can also do that. So once this device gets registered, the password is the device secret, and it uses that to log in to be able to post messages. So I think we're okay at this point. Let me save this changes, and now let's run. So once we run this, if everything is okay, we should be able to connect and provision our devices, which is now provisioned. And now we have started sending data. So you can see here it says updating MQTT broker, data sent to mqtt.publish.telemetry. So basically we started sending data. So if we were to refresh this, we should see all our provisioned devices. So you could see that all our devices have been provisioned. We have our gateway, which is WOKWI 001, which is our ESP-32 device. We have our humidity sensor, right? The blue LED, the red fan, thermometer, blue fan, and red LED. So all our devices are now registered, right? So let's go ahead and go to telemetry. You can see some of the data that we're getting right in the last hour. Right, so if we go to brightness, you can see the blue LED and red LED brightness are there. Right, if you close that, you can look at that also, right? So basically you can see data coming in, and then on this table also you can see some of the data. Everything looks okay, just very similar to what we've gone over previously, right? So if we go to, let's say, sensor, right? Because we're using sensor for both the thermometer, the sensor profile we're using for thermometer and humidity. So you could see the humidity right now, right? And the temperature, the thermometer has a 21 degrees, I think it's Celsius. So we have a Celsius thermometer right there. So now, if we were to connect, right, let's see what happens, right? So once we connect, we can see we start getting data, live data coming in, right? And now, as we get new data every 10 seconds, our chart is being updated, right? So you can see data coming in from our chart, and basically you can see that this is quite good. Like, new data comes in, and we're able to get all that data here. So now let's put on our red LED. So if you put on the red LED, so once we get the next update, so where is red LED? Okay, here it is. So you can see the red LED is now on, right? And the brightness is at 100%. And if you click on the blue LED, so blue LED, you see the blue LED should come on, right? Yep, so it's 100% and on, right? And now if you turn off the red LED, right, it should also be off, right? Now these buttons for the fan work a little differently. They increment about 25% each time you press it. So there are two types of switches you can do. You can see there are two types, a toggle and an increment. And for the increment, it usually increments, like you can set that, but the default is 25. It increases by 25, and then when it crosses over 100, it will reset back to 0. So let's just go ahead and minimize that. And now we can just put on our red fan, and now this is the red fan. You can see it's on, it's at 25%. Once we click on it again, and that should be 50, right? And let's click 2 more times, and that now should be 100 the next time it updates. And we can also click our blue fan twice, and we should be at 50, right? Where's the blue fan? So here it is. So when it comes on, it should be at 50. We can click a third time, and it'll be at 75. So the switch class actually helps us manage all that, so that we don't have to write a lot of code. And now we can reduce our humidity to maybe 40, maybe increase our temperature to 49. And once that's done, our humidity is now 40 and our temperature, yep, so thermometer is saying 49, just came in. Okay, so you could see 49.1, right? So this pretty much works well, right? And all that data now, as it's coming in, you can see all that. You can see where we had the 40 and 49.1, right? And when the new data comes in, you can see how all that is changing also, right? You can try this out. This works pretty fine. That's just interesting how you can put this together easily and use it. And again, if you wanted to host it on a real device, like we would do now, you could also do that. And it should also work, right? So let's say we connect again and we put on our blue, and maybe blue fan is at 50, right? So blue fan should come on now. It should be at 50, and then blue LED is on, right? So if we look for blue LED, sometimes it's hard to find all this, is on at 100%. And again, if you wanted to do controls like we talked about before, so basically I could turn off my blue fan, right? So if I went to blue fan, right now it's on, I can change the state, and I could just say, okay, I want the blue fan. My CSS is, I didn't fix that yet. So I could send it and you can see the blue fan comes off, right? And same thing if you wanted to set the speed of the blue fan, you could maybe say 30, right? And when you send it, basically it comes on at 30, right? So you can see that. You can also do that for your red fan. Also, you could set the brightness to maybe 20, right? And then when you send that, oh, red LED, oh, not red fan. Okay, so the red LED should come on, yeah. So you can set your red fan, so red fan, and then let's set the speed to 20, let's say, yeah, 20, we could set that, and then that should come on. So pretty much works right out of the box. You can install it and just see your data come in and just test it and see how it goes. So let's go ahead and download the code and install it on our ESP-32. So I'm just gonna take this off the screen and then I'm gonna download this code. Again, if you've run the simulator, I think you could, right? You should be good. So I'm just gonna download this. So I'm just gonna open the files that I need. So I'm gonna open the files. So we need the main.py open. We need LED-PWM, open that. I don't need this, let me cancel that. We need helpers.py, open. And then we need environment settings, and then we'll open it. Now, for this, we're going to use, I don't know, you could use the same project. Let's just use the same project and see how we can run both together. All right, so basically we have this project, right? We have the group, right? We created a group ID. Now, the device ID, we can't use this device ID because we already used it for the other one, so it's just going to override it because device IDs are unique in the database, right? So what we're going to do is we're going to change, so we need how many IDs? 1, and then there's 6 here, so we need about 7 IDs. So let's go ahead and generate IDs. You just need to get a UUID generator. So this UUID generator.net is pretty good. So we're just gonna maybe 7 for now and generate, right? So UID4s. So we'll just copy that. Seven, 9. All right. So where is my Tony? So the first ID I need is the device gateway device ID. Right, just paste it there. And now we need an ID for a red LED device. Okay, so now let's go ahead and set all the other IDs. And once we're done, we should be good to go. Okay, so now that we've put in all our IDs, our device name needs to change, right? So we're just gonna call this ESP-32. And now we are also going to change our Wi-Fi SSID. So I'm just gonna change that. It's my SSID and password for my Wi-Fi here in my home. So let me do that. Okay, so now that I've put that in, I think that's all we need, right? So I'm just gonna go back to main. So now let's save these files to our ESP32. So first things first, just connected my ESP32, stop anything that it's running to make sure we can access it. And then we'll do file, save as, and then MicroPython, and then this is called main.py. Okay. And now the next file is the ledpwm.py. So we'll do that, file, save as, MicroPython, ledpwm.py. Okay, now we'll do the helpers, helpers.py. Okay, and now we'll do the environment settings. So for that, because of my password, I'm just gonna do, but it's pretty much the same thing, file, save as, env settings. And now we have all 4 files saved at this point. And now we can run our application. So let's run it, see if it works. It's connecting, and our application is connected. So you can see that it's connecting just like we had in the simulator, right? And we'll just check. I'll have to set up my camera there so later. So let's go back. So you can see we got more devices in there. So our initial device was Walkway, and we had the humidity and blue LED, red fan thermometer for Walkway. And now we have the ESP32 device, right? And you see we have all those devices for our ESP32. So now let me go ahead and connect my camera, and I will be back. Now we're gonna put on my real device, the ESP32 device. So let's put that on. Now the LEDs and the fan are on. And once it's connected, everything shuts back off, right? So again, we have all the devices. There's a bunch of devices, a lot of devices here, I guess, right? There's so many devices, right? And there are 2 gateways, the actual ESP32 and the Walkway. You can see there are 2 gateways, and they have all these devices connected to them. And now if we go to telemetry, we'll see like a lot of stuff here, right? So for example, this is, let's connect, and let's see, it's kind of hard to figure out which is which, right? But once the data starts coming in, you can see the thermometer for the ESP-32 is saying 24.2, and the humidity is about 44.4. That's the temperature right here, right now in my room. And you can see the thermometer for the Wokwi is saying 18.2, which is what we have here, right? And we can increase that to 32.1. And the humidity is 45.5, which we could reduce down to 38.5, right? And you could see that got changed, right? And basically you could see that there's the humidity for Wokwi, temperature for Wokwi, humidity for our real ESP-32 device, and temperature for our real ESP-32 device. And now let's assume, so this is our blue fan for the ESP-32 right here, right? And this is the state it's off, right? So let's try to put that on and see what happens. So I'm gonna try to put the blue fan on. So the blue fan is on and it's at 50. So let's get the red fan on. And our red fan should be on and it's at 25, right? And so let's go to motor down here. Speed rather. So you could see, and that's the 30 minutes, right? So you could see our red fan and blue fan, right? So they're all there. Our data is right there, right? So if we make the red fan 100, let's see how that works. That's the red fan. Hopefully we're still connected, right? And red fan is now at 100, right? Red fan ESP-32, and you can see that up here. Red fan ESP-32 is at 100, right? So colors are a little bit not clear, but pretty much it works, right? And if we wanted to, so both devices, both gateways are connected, and we can actually view whatever, we can control them also. So let's say we wanted to turn off our red fan from the ESP-32. We could set the state to off, and we could just send a command, and that should come off. And we could do the same for blue fan ESP-32, and we could just set the speed to 0, which should turn it off, right? So basically we can do, basically both. And if we were to do, like, if we wanted to control the fans, which is this side for the Wokwi, right? So we could do red fan for Wokwi, and we could set the speed, and we could say 75. And once we do that, the red fan should come on right there, right? And we could also turn on the blue LED for the Wokwi, right? So if we do blue LED Wokwi, and we do state, and we do on, this is the blue LED. So when we just send that, blue LED should come on. Same thing if we wanted to turn on the blue LED for the ESP-32, we just do state on, and we'll set that, and it comes on. And we could do the same thing for the red LED for the ESP-32, state, set. We could even just do brightness, and we could set the brightness to maybe 60. And once we do that, it'll be 60. So we can reduce that also to like 40. Let's see if that goes. They see it comes down. We could get it down to maybe 20. Yep. So, oh yeah, it's on a little bit. It's kind of blinking, flashing. So let's take it up a little bit to 30. So essentially, you can do a lot. You can connect as many gateways, as many devices as you want, and control them. Please feel free to like, comment, subscribe, and share these videos. And hopefully I would see you in the next one. Thank you.